So hi everyone, welcome to the notes for target 3 of the Pythagorean Theorem. And at the end of this lesson, you should be able to use the Pythagorean Theorem to find the distance between 2 points on a coordinate plane. So we can see in the two graphs that sometimes it's easier to find the distance between 2 points when they form a straight line using the grid. So when we look at graph A, all you have to do is count the number of squares and use the units on the axes to find the distance. So in graph A, the distance between those 2 points is 3, because all you have to do is count the squares. However, in graph B, when we look at this graph, it's a diagonal distance, so it's harder to count the squares. We have to use the Pythagorean theorem to find those points. So we have some steps when we find the distance between 2 points using the Pythagorean theorem. So in some cases, it's just going to give you a set of points. You have to plot yourself, so you have to do that first. Then you're going to use a ruler to draw a line connecting the 2 points. Then you have to determine if you can count the units between the 2 points, like in graph A, or if it's a diagonal distance that's not countable, such as graph B. If you're finding the diagonal distance, you need to create a right triangle using the 2 points. And we're going to do this in a similar way that you created slope triangles back when you did linear. And finally, you're going to use the Pythagorean theorem to find the distance between the 2 points. And so the diagonal distance between those 2 points is going to create that hypotenuse, or that side C. So let's take our first example we have. So we want to find the distance between these 2 points. So since they're already plotted, we can skip step 1 and go straight to step 2, where we draw a straight line connecting them. So I'm going to connect point A to point B. And your guys' line will be straighter than mine because you're using a ruler. And then we're going to try and determine and see if we can count that distance. So we see it's a diagonal distance, so we're not able to count it by hand. So now I'm going to create a right triangle using the grid lines on the sides. And we're going to go straight down on this side. And then we're going to go over to this side. So now you guys can see how it forms a right triangle. So now I'm going to count the number of squares that these lines take up to find the lengths of the sides. So from side this red line right here, if I count the number of squares, it's going to be a length of 1, 2, 3. So this side is 3 units, while this side, 1, 2, 3, 4, is 4 units. And since that side length that we're trying to find is opposite this right angle, that's our hypotenuse for side C. So now we're going to go all the way back to target 1 and begin by labeling our variables. So A equals, B equals, and C equals. And I'm going to call side A the side that's 3 units. Side B is the one with 4 units. And side C is going to be that question mark. So again, we're going to follow through with A squared equals 3 squared, B squared equals 4 squared. And then we know that 3 squared equals 9 and 4 squared equals 16. And now we're going to use our Pythagorean theorem formula. So we have A squared plus B squared equals C squared. We're going to take the value of A squared, which is 9, and substitute that into the equation. Now we're going to take the value for B squared, which is 16, and substitute that into our equation. And we're going to leave C squared alone. Now we're going to add up the 2 lengths together. And so 9 plus 16 equals 25, and that equals C squared. And lastly, we're going to take the square root like we've been doing. So the square root of C squared and the square root of 25. And we know that the square root of 25 is equal to 5. And so that tells us that our distance between point A and point B is going to be 5 units. So now we're going to take this second problem. So this one just has an extra step. The points aren't plotted for you. So you're going to have to take the time to plot the points first and then find the distance. So first, let's plot the point negative 6, 1. Remember that the first number in any coordinates is going to be your x value. So let's count over negative 6, and then we're going to go up positive 1. So that's this point right here. And then we're going to put our second point of -4, 5. So I'm going to go on the x-axis over to -4, and then on the y, I'm going to go up to -5. And that's this point. Our next step states that we're going to draw the straight line distance between the two and connect them. So I'm just going to connect them with a straight line. And now we determine that this isn't a countable distance because it doesn't fall on the grid lines. So now we're going to connect them using a right triangle, similar like the slope triangles that we created. So we're going to go down on the y-axis, and now we're going to run. I'm going to draw this little right angle. So it's easy to see what side is the hypotenuse, which is the side directly opposite, or C. So now we need to count the number of squares that this length and this length take up. And so when I count the blue side, I see it's only a length of 2. So I'm going to label that with a 2. And then when I see the green side of the triangle, I see that it's a length of 4. So I'm just going to label that side with a 4. And now we're going to go back to target 1 again and label A, B, and C, plug it into our formula, and then solve for the length of C. So now we know that A equals 2, B equals 4, and C is that question mark. So we have A squared equals 2 squared, and B squared equals 4 squared, and 2 squared equals 4, and 4 squared equals 16. And then we take our formula of A squared plus B squared equals C squared. Then we're going to substitute the value of A squared in and the value of B squared. You get 4 plus 16 equals C squared. Then we add up that 4 plus 16, which gives us 20 equals C squared. And lastly, we're going to take that square root on both sides. And the square root of 20 is 4.5 units. So if these problems don't specify any type of unit, we just end it with units. And that is the length between the point -6, 1 and the point -4, 5. And then you'll see that the next problem says on your own, so I want you guys to take some time to do that problem independently. Okay, now that you guys have completed finding the distance between 2 points on a coordinate plane independently, now we're going to take that and apply that to a problem where we need to find a perimeter of a shape on a graph. And so there are similar steps where first you need to determine if you can count the units between the 2 points, but then you also have to determine if it has a diagonal distance, it's not countable. And then if you're finding the diagonal distance, again, you're going to create that right triangle. And we're going to use the Pythagorean Theorem again to find that length. But then after finding the lengths of all your sides, you're going to add all those lengths up to find the total perimeter. So let's take this first problem together. So here we have a triangle on a graph where we have 2 sides that aren't countable because it has that diagonal distance. But then we have this side that has that distance that falls on one of our grid lines. So we're able just to count that independently. So first let's start by counting that straight up and down side, which is a length of 4. So I'm just going to label that one with a 4 first. So now we need to find the length of these other 2 sides that we have. So I'm going to start first with this side. I'm going to do this one all in red, so it's easy to tell where our calculations are coming from. I'm going to draw in a right triangle. And now I'm going to count the side lengths of that triangle. So you can see that this side right here has a length of 2 units. And then this side has a length of 5 units. And then I'm going to draw my triangle for the other side and see if it's the same. If it's the same, then that tells us that the measure of both this side and this side are going to be the same length. So now I'm going to draw that triangle with green lines. And now I'm going to count the lengths of those sides. So now I see that this triangle also has a side of 2. And it also has a side of 5. So now that we see that because this triangle that we created has the same side lengths as this triangle that we created before, that tells us that both of the hypotenuses are going to be the same length. So we only have to do one calculation. So then we go to our next step where we're going to label A, B, and C. So we have A equals, B equals, and C equals. I'm going to say that A equals the 2 units, which is right here. And then B equals 5 units, which is this point right here. And C is that hypotenuse, or the side of the triangle that we're solving for. So C is going to be that question mark. Now we're going to solve for A squared and B squared. So A squared equals 2 squared, which equals 4. And B squared equals 5 squared, which equals 25. Now we can take our Pythagorean theorem and solve for C. And then we have A squared plus B squared equals C squared. And then I'm going to substitute the value of A squared in, which is 4. So we have 4 plus the value of B squared, which is 25, equals C squared. Then we take 4 plus 25, which gives us 29, equals C squared. And our last step is to take the square root of both sides again. And then 5.4 equals C. So now I can write in those side lengths right on the picture. So now we can see that the length of this side is equal to 5.4 units, the length of this side is equal to 5.4 units, and the length of this side is 4 units because we can count the squares. And then the final step when finding the perimeter of a shape is to add up the lengths of all your sides. So now I'm going to say that P equals, and P is for perimeter, 4 plus 5.4 plus 5.4. Because we have two sides of 5.4, that's why we're adding it twice. And so that's going to give us 14.8 units. And then you'll see I gave you guys another figure right below this. And you guys will have to do the same thing and figure out the lengths of all those sides and add them up and see if any of them form the same triangles that you create so that you only have to do the calculations once. And then that concludes the set for the target 3 notes. And remember, just let us know if you guys have any questions.